Okay, so I hope you enjoyed the morning tutorial. I think it was very informative, but now in this afternoon, you have the chance to actually use what you learned and implement some small exercises in P4. So we've created about 4 hands-on programming exercises for you to go through, and we've prepared the virtual machine with all the tools that you'll need. So skeletons of the exercise, the P4 compiler, Mininet, a software switch, BMv2. Again, if you didn't already have the copy of the virtual machine, can you let me know or let one of the instructors know? There's USB sticks floating around where you can get a copy. And most of these all these exercises are designed to sort of work at your own pace. So don't feel the need that you have to finish all of the exercises today. Take your time, work at your own pace. If you need help, there's a few people floating around to help you out. So my name's Robert, you can ask me. There's Cole standing up here, Masood, there's Masood there in the back, Han, and Antonin also. So these are the instructors floating around. If you need help, you can raise your hand and they'll come and help you out. But remember, there's only about 5 of us here and there's, I don't know, 70 or 80 of you. So we can't be everywhere at once. Feel free to work in pairs, ask your neighbor for help. This can be collaborative. There's not going to be an exam at the end. So when you start up the tutorial, you'll see that there's the virtual machine, you'll see that there's a username is P4 and the password is P4. I hope you guys can remember that. So let's just sort of walk through this together by hand. Why can't I see this? Oh, okay, hold on a second. Let me fix this. Display. It should be mirror. Why is this not? Okay. Is this working? Is this going to mirror? Sorry, I'm just trying to mirror the display, but otherwise, you type P4, log in. I have it here. Oh, okay. These. Sorry. Yeah. But I can get by without it if we need. Vlad's slides are going to be available shortly with all the instructions. This is just going to introduce you to the VM, but we can also make these available. There we go.
No, it's frozen.
There you go. Oh, thanks. Okay, so when you log in to your virtual machine, again, the password's P4. You can start up a terminal. And you'll see a command prompt. In that directory, there's a directory called P4 tutorial. Go into P4 tutorial, and then one deeper to P4D2_2017. So P4 Developer Day 2017, and then exercises. So here we have the 4 exercises that you'll need to complete. Let me come back to them in 1 minute. The other thing you can do is start up Mozilla, and hopefully this will go right to the GitHub repository where there's a README describing each of the exercises that you can go through step by step. So the first one is L3 forwarding. If you just click on that, slowly going through. And go down the README. It has step-by-step instructions of exactly what you need to do and describing the workflow. Now, let me go back to the slides for a second here. Okay, so like we said, first go into the directory. You can ignore the git pull. We didn't make any updates. Start Mozilla. You'll see the README for the tutorial page. Now, there's 4 exercises that we've given. One is L3 forwarding, which is just simple forwarding for IPv4. There's MRI, which is a scaled-down version of our in-band network telemetry. There's an ARP ICMP responder in which you implement a switch that's going to respond to ARP or ICMP requests, and then a calculator that executes basic arithmetic expressions and returns the result in a custom packet header. So for each exercise, there's some starter code and a test harness. I'll walk through the workflow in a second. And there's also step-by-step instructions in the readme.md files. So you can either read just the text or you can pull it up in Mozilla. Okay, so the first exercise is IPv forwarding. The key tasks here are that you'll need to update the source and MAC address. You'll need to decrement the TTL and then forward out the correct port. So this is designed to be sort of the starter exercise. And we've written out step-by-step to-dos in the skeleton program of what you're supposed to fill in. The next task is the MRI multi-hop route inspector. The idea here is that you're going to have a custom header that contains the switch ID, and every time a packet arrives at the switch will append this custom header with the switch ID, and then when a packet arrives at the destination, you can print out the sequence of IDs through which the packet traveled to learn the path that the packet traveled through the network. Next is an ARP ICMP responder. The idea behind this exercise is that you're going to use the IP forwarding table as sort of a database for containing the data that you respond to ARP ICMP requests. So what you need to implement is you'll add headers and logic to respond to the ARP and ICMP requests, and then afterwards you'll be able to respond to pings on behalf of hosts connected to the network. Last is a calculator. This is sort of an oddball thing, maybe not that you'd really want to do in practice, but it really shows off that you can, P4 is just another programming language, and you can implement whatever types of programs that you want. So here you have a custom header with an operator and 2 operands. The switch will perform the operation and return the result, and then return the result back to the sender, and that basically the network is acting as a calculator for you. So if you're stuck, I already point out there's several instructors around the room. Raise your hand, we'll come by and help. Feel free to work in pairs, small groups, work at your own pace. You don't need to finish everything today. The main idea is just to have fun and to enjoy learning P4. So let me show you how we can sort of step through the workflow of starting on the first exercise. So again, let's pull up the terminal where we're in P4 tutorial, P4D2_2017 exercises. The first exercise is IPv4 forwarding, so we'll go into that directory. You'll see a bunch of files in here. Most of these you don't really need to worry about. We've tried to make this as simple as possible. The main one that you'll need to worry about is the one called IPv4_forward.p4. This is a skeleton program for what you'll need to implement. Just sort of slowly scanning through it, at the top we see some header definitions for Ethernet and IPv4. This way you guys don't need to go and look up what all the protocol fields are. Metadata that you won't need in this exercise, the header definition is already done, and then we get to a parser, and you'll see that there's a to-do here that says when we start, we need to transition to parsing Ethernet headers. So right now it's stubbed out, it just says transition accept. You'll need to modify the logic to parse Ethernet and then parse IPv4. We've put some other stubs in here for the parsers. Going down, there's the checksum verification. Now, for our purposes, you don't need to worry about that. In a real switch, you might, or you would, but here you can safely ignore that for now. Then we have the control block, and again, you see there's an action for IPv4 forward with a bunch of instructions in the to-do comments, a table for doing longest prefix match on IPv4 packets. Again, there's to-do notes of what you need to fill in, and finally this apply block. Then we come to the egress processing. You won't need to do any egress processing for this example. Checksum computation, you can ignore that for now. And then the deparser, we've already filled out the logic for you. And finally is the package instantiation, which again is already filled out for you. So you should be able to follow along just at wherever it says to do and fill in the logic for what you need to do. So how do you test if it's working or not? In this directory, and in fact in all the directories for the examples, there's a script called run.sh. What run.sh is going to do is it's going to invoke the P4 compiler on this P4 program, and then it's going to start a software switch and also start up an instance of Mininet. Have you guys used Mininet before? Most of you are familiar with Mininet. So if I do that right now, I type run.sh, P4 is the password again. Now, it compiled the stub code with some warnings and errors. Those will go away once you've filled in the stubs, but we start an instance of Mininet. So if we type nodes, we see that there's 3 switches. They're connected in a triangle and a host connected to each of the switch. Once you've completed this exercise, you should be able to send traffic from one to the other. So the way that you would do that is now we can open up extern windows on H1 and H2, say. And on H2, we have a program that's going to act as our server, so we can type receive. And this will start up, and we see a message, sorry, the small size, but it says sniffing on the interface that's sniffing on. On the other side, we can type send, and since we want to send to node H2, we would type in 10.02.10, which is its IP address, and then the message we want to send, say P4 is cool, and we see from Scapy that we crafted the message, but it didn't reach the destination. That's to be expected because we haven't implemented our switch logic yet. So when it's working, we should see the packet arrive on the other side. Make sense? Good. So that's the basic workflow. All of them should be the same. Now, I've kind of glossed over some details here. One is that once you've defined your IPv4 tables, that you'll want to install some control plane rules. We've already written the proper control plane rules, so if you exit out of Mininet, you'll see some files in here, s1 commands.txt, s2 commands.txt. You shouldn't need to edit these at all, but the run.sh script will automatically populate the corresponding switches with those control plane rules that will just allow you to focus on the data plane part of the assignment, and assuming it's implemented correctly, you should be able to send packets back and forth. Okay?
And when I forgot any of the parameters and syntax, is there any example that you can?
Right. So, okay, you have a few different options here, and this raises a good point. One is that any minute now, Vlad's slides should be available online. Oh, they are available online. Prem, how do people get them?
Yeah, just go to the agenda page, p4.org/p4-developer-j-2030, whatever the agenda page you have, and the slides are embedded in the agenda. Just go to the tutorial part and then
Okay. So you can look at these slides, look up what you need to do for the proper syntax. Now, you have another option, which is that we've actually included a solution. It's to all the examples. So within this directory, you'll see a solution directory. And if you go into solution, there should be a working version of the script. If you want to cheat, you can look at that, or maybe you can think of it not as cheating so much as sort of, I don't know, a Cliff's Notes for P4 or something like this. So you can always refer to the solution if you need help. And now, there's one other file in here that looks a bit funny, which is this p4app.json. You can completely feel free to ignore that. This was just some infrastructure that we built up to specify what commands we want to run in Mininet and everything else. It's not part of the normal P4 workflow. It just helped us get these examples up and running. Okay, so again, work through the examples. They get increasingly difficult, and we provide sort of less and less help as we go along. So by the time you get to calculator, all of the skeletons are stubbed out, and there's not really any to-dos. You're more or less on your own. But the early ones, IPv4 forwarding, there's a lot of hand-holding. It says exactly what you need to do step by step. Okay? And if you need any help, again, there's instructors going around. Just raise your hand and let me know if you need any help. Thanks.